Now onto our webcast. The subject today is APIs and open banking. And APImetrics has over 3 years of direct, actual, real-world experience helping some of the biggest banks in the UK and around the world manage successful open banking initiatives. Open banking, as most people know, has a lot of potential to drive innovation in the financial ecosystem, but it also brings some risk and also brings regulatory overhead. Our presenter today is David O'Neill, founder and CEO of APImetrics. And David is the one who's been at the forefront over these last 30 years of working with banks in open banking and tackling some of the challenges associated with successful open banking initiatives. So with that, over to you, David.
Thank you, Andrew. Good morning or good afternoon or good evening to everybody joining us. Thank you for coming. So as Andrew said, we have been monitoring open banking for over 3 years now, since its inception in the UK. And what I'd like to present to you today is a distillation of some of the key lessons we've learned in the process of doing that. A little bit first, just to give you some background, who are APImetrics? Well, we founded in 2015 to solve the problem of monitoring APIs, and particularly hard to monitor production runtime APIs. It's relatively easy to do testing in pre-production environments, but actually running functional testing and meaningful testing and monitoring on production services with all of the security in the way that it works is much harder. And we also pride ourselves on being completely cloud agnostic, so we can show our customers what the world looks like from the point of view of different cloud data centers and different locations as per their users' experience. So for the data we're going to present today, we've got 3 years of monitoring the actual live production environments of UK open banking. And in that period, we've made somewhere north of 30 million synthetic calls. And these are functional consent and AISP calls made against UK banks, from the largest down to some of the very smallest traditional ones. And UK banking is very interesting for us from a data and analysis perspective, because everything is the same there. You have a common framework for security, you have a common certificate issuing authority in the open banking implementation entity, and you have very defined API calls where the security works the same and all of the API calls work the same. And what that's allowed us to do is really pioneer secure production runtime monitoring of banking APIs and identify some of the pitfalls and challenges of not just the setup process, but what that means 1, 2, or in this case, 3 years down the road. And we've been doing this for some of the largest banks in the UK and around Europe and North America, as well as some of the biggest household software names such as Microsoft and others around the world. So why we do this is the lesson that we learned very early on when we founded the company is the quality of API services is just not consistent. And this graph is here to really bring this home for everybody. What we've done is we've used a set of identical API calls over a period of 12 months, made the same way from the same data centers using the same infrastructure, and scored them using the same patented algorithm we use to identify quality. And what the algorithm does, we call it CASC scoring, Cloud API Service Consistency. It scores everything out of 10. It's a bit like a net promoter score. So no matter who you're speaking to or what the audience is, everybody can understand a score out of 10. Anything above 8 is generally okay. Anything above 9 is excellent. 10 is theoretically unattainable, but if you're in that sort of 8.5 to 9 area, you're doing pretty well. In this graph, you'll see a dotted line. That dotted line represents an average of the best IT API providers in the world. So that's the Microsofts, the Dropboxes, the Boxes, Twilio, and so forth. And they pretty consistently run at an average above or around 8.8, 8.9. And that we consider to be the baseline of acceptable performance. We're not grading on a curve, as we say in America. This is a metric that everybody should be able to hit. So what you'll notice from this is the orange line at the top are the neobanks. These are the new entrants, people who have come in to be cloud first API native new banks in open finance. And they do a lot better than other providers, but they do significantly better than the CMA9, who are the 9 largest banking entities in the UK, who do a huge amount better than the traditional banks, who tend to be smaller, older banks, traditional building societies, older credit card companies. But the discrepancy between the 3 tiers is quite noticeable. And it's certainly something to think about with the traditional banks. It's something they should be thinking about with their IT policies and where they're putting their resources and their budget, because it's accepted that they do have a technical debt. So does CMA9 with very old IT infrastructure. But there's a lot of room for improvement, and there's a lot of things they could do to get better. And some of the lessons we're going to talk about would be things that could help them, but they will help you understand as a member of the audience how you can get tripped up on the API implementation process, and not just in open banking, because the lessons we've learned, I think, apply to a lot of fields as well. So let's get into it. So lesson 1, I call it quicksand. And really the story behind this is if you are API first, you need to be API first. And the reason for the graphic is when I was a kid, I really believed that quicksand would be a much bigger problem for me than it turned out to be. I watched far too many Tarzan films and similar when I was growing up. But sandboxes, they do bog you down, but they are important. And the type of things we've seen are sandboxes that just don't look like your solution. Sandboxes that go down a lot, and by down a lot, I mean weeks at a time that they are not available. And then sandboxes are almost impossible to access, as in the gag from The Hitchhiker's Guide to the Galaxy, which we'll come back to, that something was locked in a filing cabinet with a sign on the door saying, "Beware of the leopard." We have seen sandboxes that required handwritten access to get into them, i.e. you filled in a form in blue ink and faxed it to the entity who provided the sandbox. That is not being API first. API first is having a portal everybody can access. API first is having a sandbox that looks functionally like your developer environment. One of the weak spots of UK open banking was the regulator required sandboxes to come before they were ready with their back-end implementation. So you ended up with sandboxes that were built on a completely different infrastructure that behaved completely differently to the end API. That is not something you should do. You should functionally use your developer environment and stub it off in such a way as everybody can access it easily. And what we see if we look at the quality metrics, the neobanks do this, that there is very little difference between their sandbox environments and their ultimate production environments. And that's very important to be developer first. They're the gateway to your developer experience. You should have the same security. They should have the same schemas, the same formats. And you should really focus on a metric that Postman call TTFHW, time to first hello world. How quickly can a developer, looking at your documentation, looking at your sandbox, get up and running? So focus on sandboxes. Sandboxes are the gateway to the developer experience. But that leads me on to the next point, which is documentation. And one of the key lessons we've learned here is you need to document what you do, not what you think you do. So we have seen documentation in PDF format. If you have documentation which could include, for example, a digital signing key that you use in the sandbox, you cannot copy and paste that reliably from a PDF because there will be characters in it that aren't part of the certificate. We have seen documentation that is wrong. We have seen documentation that is old, i.e. out of date, and wrong. We found no documentation at all, or, to go back to my example from The Hitchhiker's Guide to the Galaxy, it was literally locked in the locked filing cabinet. And then when you provide a sandbox, you can provide no rapid support, or in the case of some of the banking institutions, not even slow support. We onboarded the first 25 to 26 UK open banking entities in the space of a day. We are very, very fast at implementing a good design. It took us nearly a week and a half to 2 weeks to do the next block, but we had a hardcore of 5 or 6 services, which we have still not, 3 years later, been able to onboard because they do not respond to support queries from their documentation team when something is wrong. That's not acceptable. A recent example we've seen was from a large German bank where their sandbox environment and heartbeat services all went down, and the only place that we found there was evidence that they were not up was when we pinged them on Twitter and asked, and they confirmed that they were having some issues. So again, documentation needs to be key and it needs to be correct. And what we recommend to our customers and to anybody out there is don't have your documentation just written by your engineering groups. Have it tested by somebody who's completely outside of the development team and have that cross-checked regularly. It's a service we do when we onboard customers, but it's something to really think about. Developers who know how an API works, who built it, will always be able to get it working because they'll know that step 6, which they haven't written down and is obvious to them, has to be done a certain way. That will not be obvious to other users, and it will lead to friction and therefore lack of adoption of your services versus others, which is a critical lesson for all API programs, not just in open banking. So as we move on, lesson 3, there and back again. Test and monitor your calls from where your customers make them, not from where it's easy to get data. And this comes into why we set the company up in the first place. When we started looking at API performance, we got into a lot of fights with DevOps engineering teams of we could not access the service, but yet they saw no errors. And their single source of truth was either their APM stack or their gateway. Those are not necessarily going to tell you what you need to know. First of all, the cloud isn't flat, for want of a better word. Not all combinations of technologies actually work very well. We've seen multi-second differences between data centers around the world provided by the same data cloud provider. So a call made from AWS Frankfurt takes up to 2 seconds in the case of one bank, longer than a call made from another AWS data center in Ireland. Those are things that you need to check and understand. If you're in a dispute with a customer, their issue might be perfectly valid, but you're not seeing it. All you're relying on is what your gateway is telling you. If calls fail to reach your infrastructure, you will not see that call at all. And we often see situations where something has gone wrong in the load balancer infrastructure or some part of the name resolution service. And then finally, and this will become a thread as I talk through to the end of my presentation, can you prove your logs are valid to a third party? In open banking, that's actually critical. There are already disputes being raised with the FCA and Pay UK authorities in the UK. This will become a more regular part of the environment as people complain about service quality, as they try and defend themselves from their customers being upset, or they're just angry with how banks are offering a service to them. You need to check everything end to end from where your customers are and monitor like you might have to prove it in court, because in open banking, there's a possibility you might just have to. The other issue you have is, what do you do in the environment where both sides can bring receipts to prove the other might be incorrect? And honestly, the truth might lie in the middle. It could be that there is something that's down to a third-party dependent service in the cloud host itself that is causing both of the institutions to have problems. These are things you need to understand, you need to be able to protect yourself from, and you need to be able to communicate and articulate to your end users and your customers. And it's something that we've really been brought home to us with the other aspect of monitoring that I come onto, which is, at the end of the day, everybody lies. I'm going to quote my favorite television doctor, Gregory House, on this, but everybody does lie, everything lies, and HTTP codes in particular, which are the bedrock of a lot of DevOps engineering teams, lie more than others. So first of all, they don't tell the whole story. There's a lot of reliance on, if a HTTP code is 200, it's all okay. It's literally in the response of the API. But what if it's not? What if there's nothing in that API call? It says it's passed, but it hasn't returned you, for example, a failure we see all the time with large banking institutions. You ask for a list of transactions or you ask for an account list. If that account list is empty, but you've got a 200, your application will be looking for something that doesn't exist. But if you're relying on the 200 being a pass and a check mark that everything worked, you will not see that. If I flip that around, there is a tendency among a lot of engineering groups to ignore HTTP 400 errors. It's a client error. Somebody made a mistake. It could be credentials. A resource isn't there. It's usually assumed that the API call itself has made a mistake. But what if it hasn't? What if your security has gone wrong and it's not using a valid authenticator, it's not using a valid OAuth token? What if there is something else not functionally working the way you expect it to, even though in theory the 400 is the correct result? If you're just looking at the HTTP codes, you will not see the whole picture. The reason why people use HTTP codes and don't look beyond them is volume. If you're running tens of millions of transactions a day, there physically isn't enough compute power in the known universe that's economically available to you to check every single result in real time without pulling your services down to a crawl. But that's where synthetic transactions on your production environment become very powerful. You can check every synthetic result. You can do post-analysis overnight. You can actually produce information that you can use to prove to a third party or a governance group inside your own entity that you are at least checking to see for these problems. And honestly, if you start checking for them, you will probably be slightly horrified and surprised at what you see. The final point I'll make on this is a lot of this will come down to your API security. And there's a lot of focus rightly on the threat of attacks, zombie APIs, port attack, SQL injection, other parts of the OWASP security top 10. But you also need to validate that your security works the way you expect it to. Just because you can't see anything is obviously down, we see lots of scenarios where refresh tokens don't work. You have a valid refresh token, but you can't access a resource, or suddenly you can access resources without the correct tokening and everything is wide open, but it appears to be secure. So something is so the key thing here is just don't trust, verify what you are seeing and verify it's true. Lesson 5, I struggled to name this, but I came up with be kind to frogs. From the old story that a frog, if you put in hot water or warm water and start to heat it slowly, will never notice to get out. And we see this a lot in traditional APM stack monitoring of APIs, that averages are very much not your friends. Good teams do use P90 and P99 values. That's the worst 10% or the worst 1% of your results. But just by looking at averages and rolling averages, you can miss significant slowdowns. The graph I'm showing in this slide is from a large bank somewhere in the continent of Europe that we monitored. And over the course of a few months, it went from taking about 700 milliseconds, which was what the functional API call was expected to take. It's a linchpin call. It would get a list of accounts available for the consent. But over the course of several weeks, it got slower and slower and slower, but not slow enough that any particular week or day would trip their rolling average detection in their APM stack. We kept pointing it out as an outlier, and the CASC score kept getting worse and worse, but they didn't pay attention to it until we were able to show that they were consistently taking an average of over 12 seconds per call. Yes, seconds, not 1200 milliseconds, but actual 12 seconds. And that's the kind of thing that we can see. Rolling change detection can be easily fooled if you're just looking at certain types of average. We've seen this where people haven't paid attention to what the normal performance looks like and have set rolling average detection that's way higher than you would normally need. So things can slow down by an awful lot before you'll trip any alerts. And in fact, if you're just looking at a period of a day or a course of a week, we've seen APIs be functionally unavailable for hours at a time, but not trip any alerts because they're normally very, very fast and they've set the threshold detection at a second or two. But the threshold detection is based on the average, which doesn't increase that quickly if the API is slow for just for relatively short periods compared to the rolling period. So check absolute changes and use some kind of, I would say, as we provide AI or machine learning based outlier detection, to actually look for those events or for those results that are anomalous for your system. Also see if it's regional, i.e. One data center or one cloud, or system wide, particularly if it's external access. We see this again and again with things like name resolution services. You may have too many CNAMEs in your descriptors. It's very slow to look up the location through certain types of cloud. Azure, for example, can be very, very picky about how you've set up your DNS service. Or in extreme cases, you might use a CDN service like a Cloudflare or a CloudFront, but then or an Akana, but then forget to sorry, not Akana, Akamai, and then forget to set it for your APIs. We've seen that where they have the DNS CDN service set up on their website, but it's not applied to their APIs, which are essentially doing brand new calls every time somebody tries to do an API call. So there are a lot of things to check, but you really should keep on top of them to keep away from the risk that they can impact on your services. So in conclusion, what I'm saying is governance, essentially, particularly in the runtime. The best solutions in the world are only as good as you can prove to a third party or even to yourself. Open banking is working. It's working well. It's had a lot of improvement after a lot of pain early on, particularly in the UK. But there's a lot of work still needed. We can see that the new banks and the new fintechs who came along later and have built their infrastructures as cloud native from the get-go do have overall better performance compared to the traditional providers. That's kind of to be expected. But APIs are something that everybody is going to have to adapt to or fade away. And there's a real risk there, as we've seen in some of the telecom sectors, of not having quality of service and suddenly finding everybody has moved to a Twilio, to a third party. Don't just rely on marking your own homework either. Don't rely on web tools that you've always used because they're there and available and you've already bought them. It's a false economy. They may mislead you. You may also rely on data that's being self-reported to regulators by the banks themselves, which might be wrong. They might just, they have a vested interest in reporting what they can report. And at the moment, a challenge for a lot of the regulatory environments is they're not asking for independent external end-to-end data. So what you're seeing is an idealized world of what idealized data of what the world looks like inside their gateway. And as I said, existing tools don't necessarily give you the cover that you need. You may have an APM stack that does synthetics, but you may have to do a lot of variations on it to get it working with your security. And as soon as you start breaking pieces of the security and ignoring the full functional flow, you are not doing like-for-like monitoring with what TPPs have. So either build something yourself or buy something from somebody like APImetrics that can do that level of validation for you. And what we provide is essentially a right-shifted API monitoring and governance platform that's over in your production runtime environment. We use the same security as your customers do. It's a low-code platform, so you don't have to do lots of scripting. You don't have to create lots of new things. Typically, in any open banking solution we've come across, we can be up and running in hours versus weeks with some of the other products in the world. And we use a lot of artificial intelligence and machine learning to spot the issues that I was talking about, particularly the trend analysis and the outlier detection. Please contact us for a demo, but I will leave you with my keyword, which is if you're not monitoring the runtime and logging it in such a way as you can show to a third party, you are not able to show to anybody that you are doing what you say you are. So thank you for your attention, and I'll hand back to Andrew to open up to any questions if we have any.
Yeah, that was great. Thank you, David. We have gotten a few questions. I encourage everybody who's still on the call to ask any additional questions for clarifications. But we got one very good question here, which is around design time. We've invested heavily in design time and API lifecycle tool chain. Why do we need to add yet another platform? It sounds like more complexity.
And the answer to that is it is more complexity, but it's also the runtime cannot be ignored. You can design everything into a system, but unless you're actually validating that it works the way you expect it to, you are operating in the blind. And what we see over and over again is unless you're validating in production environments and how they work and whether they work the way you expect them to, you will be caught out. And the things that catch you out will be potentially very expensive or very, very concerning from a risk perspective. So I think it comes back to the last point I had, which is runtime governance is going to become essential, not just for proving internally that you do things, but also potentially proving to a third-party regulator in open regulated environments, which is moving beyond just banking into healthcare, insurance, utilities in the case of the CDR in Australia, where you may need to prove to a third party that you've done what you said you had. And just by saying I have a good design doesn't solve that problem. An example from the real world would be VW. VW designed standards compliance into their fuel emission system. But when somebody actually went and checked what the system was saying, it turned out that the design was out of whack with what the engines were actually doing. And that's the kind of risk that I think we do run in the API sector of designing things in that you think are happening, but they're not actually verifying them externally in a way that you can prove.
Okay, great. Now, this one you touched on, but I think it's worth going into perhaps in some more detail from the perspective that this question was asked from, which is, what does monitoring have to do with governance, and what is the gap with traditional APM solutions of the type that we're using today? Can't APM give us what we need?
One of the challenges with a lot of APM tooling is it is designed to keep track of your infrastructure, and that's a critical part of your work. You need to know that your server stacks are up and everything is working. There often are synthetic monitoring solutions integrated with some APM tools. They tend to have been added as an afterthought. They're not API native, they're not API first. And we've seen when we've been speaking to customers, it can take 3, 4, even 6 weeks in some cases to adapt those to work with the scenarios in open banking, particularly the security scenarios. And often it requires lots of variation in how the security model works, which opens up a question of, are you then providing data on like for like infrastructure? So API first needs to be API native. You need to think about what people are experiencing from where they are experiencing them. If we look at a typical fintech implementation, an application will be talking to, or a mobile app, for example, for open banking from a third party, will be talking to an application running in a cloud data center, potentially anywhere in Europe, in the case of UK open banking. Not every, something like 30% of the TPPs we analyzed in European open banking have data centers outside of the UK, but are still working with UK open banks. So you need to start thinking about the overhead of what it means if you're on Google versus Azure versus AWS. We found, for example, IBM cloud performance is better than most of the others when it comes to the networking components. You need to factor those things into how you're building a solution and how you're maintaining it. And my last point to come back to governance is it's all about proof. If you're measuring using your APM tooling, which is an integral part often of your DevOps and infrastructure, is that going to be enough to prove to a third party that you're not just essentially marking your own work? You need to do things externally with something outside of the tool chain. You wouldn't ask, going back to my VW example, you wouldn't ask any organization to just give you their own proof that something is working. You'd want to see something from outside that. And that's what we mean by governance. It's actually looking at the runtime from the point of view of how your users consume it using tools that have nothing to do with your overall delivery chain.
That's great. Yeah, it's a nice segue actually, because someone's asking, we're already using an API security platform for doing some of the things that you're talking about today. So what is the gap that APImetrics fills? Would I use APImetrics alongside an API security solution?
And that's a really good question. Typical API security tools are doing a very important job of looking for port attacks, looking for zombie APIs, looking for denial of service attacks, looking at your API traffic and making sure that there aren't bad actors trying to access your systems. But they're not actually functionally testing that all of the bits that make what actually in open banking is an incredibly complex security handshake work. And this is something that's often left off by even quite large companies. I was speaking to an engineer from one of the big cloud vendors only the other day, and even they admitted that they don't do enough of this themselves, where just validating that in the OAuth flow, can you get in without using the correct credentials? Does it work well? Going back to my point of other data centers, does it work in the same way from every data center? And one of the reasons why this needs separate consideration is harder is things like OAuth outside of the API spec itself. It's not considered to be part of the API process. It's a separate set of things that have to be done. And therefore, a lot of API security, which focuses on, is your schema valid? Is your schema secure? Do you have any functional specification holes? That doesn't apply because we are seeing problems in things that sit completely outside of the API spec. So absolutely have an API security platform like our partner 42 Crunch has, or WIB, and then on top of that, actually run functional positive and negative checks. Can you access resources without credentials? Can you access things in ways that you weren't expecting them to? And that's something that we're going to be announcing a lot more on in the next few months as part of our expansion into better runtime governance tools for your complete API solution.
Great. Yeah, I think we have time for one more. Really interesting questions come in. Intrigued by your use of the term API native. What are the characteristics of an API native system?
So going back to the dim distant past of the history of APImetrics, but also the history of APIs, API calls look like web calls. On the face of it, everything looks like you're accessing a website. It is very easy, therefore, to build tools or to use tools that do things with websites. Websites and APIs are not the same thing. Just because it's a HTTP protocol call to access a resource, they behave in different ways, they respond in different ways, and they are secured in different ways. We built our product from the ground up, from scratch, ignoring that the web exists. We started out from the concept that APIs are a different technology that behave in a different way and must be handled in a different way. And that's essentially what I mean by API native. We are not a web tool that we thought, hey, APIs are big, we should move into that. We started from the other direction, which is APIs are a critical part of delivery infrastructures, and you need to treat them as such. And you need to stop thinking about them as an extension of your web internet strategy and start thinking about them as a critical component you need to treat in exactly the same way. And yes, we get it. We get that, particularly in large companies, sourcing are going to go, but hang on, you bought this tool a few years ago, and it has internet in it, and aren't APIs and the internet the same? Why do you want to spend more money? It's a false economy not to do it, and you need to really think about what you're trying to achieve with your API strategy and what you are doing with it. So yeah, API native, built from the ground up for APIs, not glommed onto something else that existed beforehand.
Excellent. That's great. Very interesting. Great presentation.